Video, we are going to start looking and exploring into matrices and the Matrix, and not the movie The Matrix, but the Matrix, where we take numbers, rearrange them into rows and columns. We've seen this before when we were solving for multiple equation system of equations. Is where we've seen this before. But what if we give a representation of a matrix like so? So I have the numbers 5, 3, 0, and then we have 2, 1, and 4. That's something that these matrices can do, is they could help us organize the information. For example, right now these are just numbers 5, 3, 0, 2, 1, 4. But we can represent, let's say the columns are sizes. So this is a size small, medium, and large. And maybe the rows are shirts. And this is, pants. So this will allow us to organize information. This will allow us to organize data. So we can see here that we have no large shirts but 4 large pants. All right, so that's one thing we can use matrices for. What we also can do with matrices is we could refer them to an element. We could say that A, and we've seen this before in Desmos when we've done our system of equations, but we could say that A is equal to a matrix. 7, 5, let's do -2 and 0, and 4 and 8. Okay, so the capital letter is used to refer to the entire matrix, and it is always, I want to say 100%, but I would say pretty often, majority of the time, the matrix is always referred to as a matrix A or matrix B or just A, just B, but a capital letter. And the specific elements can be referred to using scripts. And the thing that I could refer these to is like, this is J, and this is K, and this is GHI. So when I'm referring to a certain value, I can say like AIJ. And that indicates the element in row I, column J, or in our case, the value 7. The subscript lists and rows of numbers, and then the column numbers. So the subscript lists the row number and then the column number. Oh, I said 7. I meant 4 because that's I and J. In the matrix A32, so if we have the matrix A32, we're going to go to row 3, column 2. So this is row 3, column 2. And so row 3, column 2 is a number 8. Therefore, I could say that A32 or A32 is the number 8. Okay, so let's look at another representation of a matrix. Let's look at 12, 0, 2x, and 10. Then the other matrix, we're going to have this equal to, and before we had this equal to A, but I'm going to make this equal to a second matrix. 12, y, 14, and 10. Pause for a moment here and think about this. Think about if we have equal matrices, what does it mean when we throw variables in there? Okay, so these are equal matrices. They're equal to each other. In this column row, so A1, 2, we have 2x. And here in two, 1, we have a y. What would that mean for those corresponding elements? Well, with equal matrices, if they have the same dimensions, the corresponding elements are equal. So in this case, A11, which is, use the orange here. This is A11 on this column, or in this matrices. This is A11 on that matrices, and they both equal 12. A12 in the first one is 2x. And this one's 14. So here we could say 2x is equal to 14. Or x is equal to 7. We can now use this to solve for that variable. A12, so this is 1, 1, 2, 1, 2. So row 1, column 2 is 0. And that is also equal to the y. And so therefore we could conclude that y is equal to 0, and A22, which is then row 2, column 2, is 10 equals to 10. And these are equivalent. They're good. We represented them fairly well. All right, so there's some representations of a matrices. Again, we've seen this before when we used matrices to solve system of equations. They're great for solving system of equations. And we are able to use this also to organize data, just like shirts and pants are certain rows and columns, and small, medium, large are other columns. But overall, matrices are used to just basically look and organize things, organize thoughts, and just organize data, just like we did with system of equations back in those lessons. All right, guys, if you have any questions, always feel free to ask, and I will catch you in the next video.